Hello.
Hello. How's it going?
All right, how about you?
Good.
Just settling in. Not even sure who all we're going to get today.
Clark Williams couldn't make it, so I'm
Right.
coming on his behalf for him.
Okay, great. Thank you. Morning.
Good morning.
There's Raphael.
I had not planned on being here, but my conflict resolved itself by canceling.
I was getting ready to say, Clark, I was surprised to see your name appear.
Well, that's why I asked Brian to be here, was to cover for me, but, now you got double the fun.
That's right.
Oui, c'est une version ultérieure de. Enfin. Ouais.
Good morning. Right. Afternoon, I guess.
Ouais, j'avais vu ça, ouais. C'est plutôt sympa, ouais. Je te laisse, a priori. Ouais, je sais pas si tu seras encore à 18h, mais. Ouais. Bon, bah, je reviens de voir. Après, de toute façon, à 19, moi, je suis au dojo, donc. Ok, bah, tout à l'heure. Merci, salut.
Oh, so I suppose we can, we're not really we don't really have anything to dive into because we don't have a set agenda, but I thought it would be great if maybe Ian could give us a little bit of an update on where things are, or I was hoping that Pierre would be here as well.
Hello. Yes. So can you hear me?
Yes.
Okay.
Oh, you're outside.
I'm not where I expected to be.
No, we can't hear you. Sorry.
Thank you. All right, Alex. What's the correct way to pose that question?
I don't know actually.
I think I got it right. My favorite is, am I inaudible? There's no conceivable, sensible answer to that question. I believe it's fair to say that we're tantalizingly close to being able to contribute some visible work to the SIG based on some of what we've done internally. Some of that will be based on sample builds that we've been doing and a pipeline to create those, and we're hoping to use that also as a demonstration of how we're going to consume the stream of updates that come from CentOS Stream more generally. So basically keeping abreast of the changes that are happening in what may eventually flow into RHEL, which will also be relevant to what we're doing. And then I think we're also on the verge of demonstrating a little bit or bringing a little bit to the table about what we're thinking about the kernel configuration for the Red Hat Automotive product anyway. And I could potentially put another call participant on the spot and ask for, we could go into whatever level of detail people want on that. Some of it is very much related to the particularities of how we choose to build RPM packages versus how we manage the upstream source. But yeah, so that's my initial read on that, Jeffro. Was there anything else in particular that you wanted to narrow in on?
No, just kind of wanted to get a high-level picture of where we are with the infrastructure and the code that's going to eventually go into the infrastructure.
Yeah.
And
Problem with all of that, the
Go ahead.
problem with doing what Ian wants is that it's all kind of wrapped up in, well, you got to get the configs right, you got to change some infrastructure down there to in the packaging side of things, make files, scripts, spec file template, that sort of thing. So, I'd like to be, we've got Raspberry Pis running RT kernels with Fedora right now, with a Fedora rootfs. But I really want to get to the point where we've got a package, call it kernel-auto, that's an RT kernel with, appropriate configs that we can then drop that into the CentOS SIG distgit tree and, generate quasi-official SIG builds.
Mm-hmm.
Or I guess official SIG builds with it. But what I don't want to do is drop in the existing infrastructure and start generating kernel-RT packages, because that implies a different. That kernel-RT is the is the enterprise Linux real-time kernel, and I kind of want to have something that immediately the package name says this is automotive.
Thank you.
So
Yes, that will make certain people very happy, as you know.
Yeah, I just want to. I don't want to. They're both going to be real-time kernels built slightly differently, but I just don't want to have the confusion of, well, we start out with kernel RT and then we have to shift over to kernel auto. So anyway, that was what I was hoping to do the next week or so.
Others on this call may know better than I, but I'm hoping that much of what we do here in terms of building content that's unique to the SIG will be pretty familiar. I know there are long-running CentOS SIGs that have created alternative content, that lives outside of what is normally part of the RHEL package set. We may have set ourselves up for an interesting initial challenge, because what Clark and the team are hoping to do with this kernel is have a great deal, essentially share the primary source with the CentOS 9-stream kernel, which I think there are good reasons for that, but it just happens to present a bit of an infrastructural challenge to us that, frankly, is probably not of great interest to the majority of people on this call. They just want to see the output, but it is real, and we'll have to work through it. So, alternative, if people want to go down the rabbit hole of how a bill becomes law, I think we have an animated short that we could show about how a package becomes how source becomes an RPM.
I'm a bill. That's the Schoolhouse Rock thing. Sorry.
Yes, I know. We could actually. I'm thinking maybe we should do that.
How about how a build becomes law?
How a project, how an upstream project becomes an RPM.
I'm just a build. Oh, sorry.
Got quite a lot of musical talent in this team.
Yeah.
Yeah. Okay.
Well, but I'm really hopeful that I think that this being able to show these things, and will be real tangible things publicly, is going to be an important step for us. And I think hopefully will first of all be a model of the kind of thing that we would hope to do in the SIG, and a point for further engagement with other people. So.
Oh, I mean, there's nothing wrong with diving deep, given that this is a informal meeting, so we don't really have a set agenda. The other thing we could do is up level a little bit. I want to make sure that everybody who's on the call who is not from Red Hat understands this is not a Red Hat show. This is just the initial contribution that Red Hat is making into the CentOS SIG show. And
I'm totally disappointed with that.
You were hoping it would be a Red Hat show?
Yeah, definitely.
Okay.
Yeah.
Right.
All musicians, as far as I can see.
It's definitely Friday today, isn't it?
I start spinning sticks, then it'll get bad because I'll drop them and it'll make noise.
Yeah.
Okay, let's go for it then.
Right.
I think live performance via video conference does not work. This is the
See, I
So
didn't even drop.
you practice during meetings. It's great. I can just barely see the video artifacts.
Oh, well, I've got my little practice pad here and a little practice. So, yeah, I can actually practice during meetings when I'm not officially speaking. Not that I
That's
would ever
great.
do that with your meeting.
No, I would think so. There was a great story when the pandemic first started of somebody who set up another screen in front of and they had filmed themselves being on a meeting. And they set up another screen in front of their camera so that they could go off and do things, and it still looked like they were, being in a meeting. Brilliant.
I can still keep
Oh,
threatening to set up a drum kit back here so that I can perform
yeah.
rim shots when somebody says something witty.
Oh, that could get dangerous really fast.
Yeah.
I'll be very cautious on what I'm saying then. Guys, I just had maybe a technical questions for you because you were talking about the build infrastructure.
Mhm.
When we on IoT BZH on the RedPesk side, we use Koji and the ecosystem around Koji to build our distribution. My question is really stupid, but why would you use anything else than Koji to build CentOS Automotive? Or why we should use something else?
It's a great
no.
question.
We're going to use Koji.
Yeah.
We have tag structures set up in the CentOS Koji to do this. What I was alluding to when I said what Clark's going to do will make people happy, that was not actually true. What Clark's going to do will avoid making
Clark doesn't make
some
people happy.
people unhappy. Is what I'm overselling it, but yeah, we have. And again, this is inside baseball, and I think not terribly interesting, but we do want to make a clear distinction between packages that are built in this SIG that are targeted towards automotive versus there's a very specific set of packages that are now being referred to as CentOS Stream that really are a preview of what is being contemplated for release in RHEL. That's one of its key functions. And we want to make sure that that distinction is very clear. As I said, we've made that a little challenging for ourselves by making the first package that we look at the kernel for which we want to share source, but provide different packaging in the automotive context. So it's into
And once again, as part of the inside baseball sort of thing, we actually have 3 different instances of Koji floating around, one for RHEL, one for Fedora, and one for CentOS. So that we kind of have to pay attention to that, but for the most part, the rest of the world does not.
I have to say that it's a very special group where everyone agrees that Koji is the right thing to do to build a package.
You mean there are some?
When someone says, "Why would you use anything other than Koji?" and we all nod and say, "Oh,
You're
yeah,
like, yeah, that's great.
thing to do."
My people are here.
Yes, we're all in the right room.
That's right.
It's okay. I won't do any joke regarding Yocto or OBS or something like that. I promise.
That's right. No, and there's some great. I mean, okay. So let me up level briefly. There's no reason why we wouldn't also encourage if people are okay. So let's be honest. We know that the activation energy, the learning curve for building through Koji is a little higher than some other things, and we do have Coper available through the Fedora and CentOS projects, and that's a really easy way to get some initial package builds going. So we wouldn't, that's not out of bounds for anyone who wants to contribute to the SIG as well. It's just that in our case, we want to from the get-go demonstrate a workflow that is sort of comparable to what the CentOS Stream is meant to be for RHEL, but is also clearly distinct and reflects what we're contemplating for the automotive product. So,
if you want to start a fight, you can just have a debate on whether it's Coper or Copper.
Yes, but I have a
I think
rule. Meetings I have any influence over. I have a rule
Me,
about naming discussions, Clark. I think
me, troll.
it's
I'd never do that.
how long
yeah,
have you been
I think the
running
point is,
the? Oh, sure.
yeah,
Go
sorry.
ahead, Stefan. Go ahead.
Uh, yeah,
Yeah.
just for me, the point is that if the SIG wants to drain some kind of adoption, then the process should be easy for people. I mean, you should know where your sources are, what you
Mhm.
have to push, or where you have to push your spec file, where the Git package is. Something which is already documented, and I mean the workflow is already known from Fedora community or CentOS community. So we shouldn't reinvent the wheel here. But obviously, the components we build are specific. That's the point. So sticking to the usual workflow is, I think, is essential, because this is not something you want to reinvent probably, and you want to get all the patches and all the evolution on Koji and other products coming for nothing.
No, and I think what I'm kind of orbiting around is there are right and proper reasons why the onboarding of a package into the Koji infrastructure is a little bit more complicated than building a package in Coper, and we don't want to discourage people from getting their feet wet in Coper first. The lesson that's
I,
become more and more clear to me over the years is that having a very quick onboarding experience for almost anything is good, even if it's a road to something else. Sorry, go ahead, Steve. I'm talking
I
about
was just going
Koji,
to
and
say,
yes, they have a core contributor here. So
I think that that's probably a really good example for why we need to make Koji more approachable
mhm.
for people. Because currently I don't believe that it is. I think that if you have the experience with being able to, if you've learned how to use it, then you're sort of lucky. If you're if you're on the outside looking in and you want to learn how to use it, it can be daunting. So I think that's it's a good reason for why we should make it more approachable. At least
Mhm.
figure out how to make it more approachable.
You guys see Miroslav Suchi's video on describing what a dist-git is up on YouTube?
Does it
Like,
have animation?
no, it doesn't.
Yeah.
But he's pretty animated, uh, and post a link to it. I guess it was.
Does
Yeah.
it
I thought it was a nice
does it
video.
start off does it start off like on the steps of Congress?
You're right.
Oh no, I'm just a bill.
Well,
So,
I mean, since we're ideating on this, Steve, like I feel like there's really two things that have tended to make it a little bit unintentionally exclusionary. One is purely that to get a named package and a tag set in Koji is tightly tied to a package approval in things like Fedora and RHEL, which is a pretty significant process. And then the second thing is just that the workflow itself has a slightly steep learning curve. It's not that complicated. Um, Whereas Coper is entirely self-service. We have no notion, as far as I know, of a self-service addition of a package to any of the Koji build systems because they're very carefully curated. And we tie a bunch of things together. The creation of that name package has to have an owner. It has to have a life cycle. It implies it also ties into the reason why we're being advised to be very careful about whatever we build, making sure that there's no implication purely by where it lands in Koji that it's going to end up in RHEL. These are things that people get concerned about. So
Yeah, but there's no reason that you couldn't stand up your own Koji and build directly from the source tree.
yeah.
Not to necessarily
Oh
be
yeah.
included within, an official distribution, but if you're making your own official distribution, right? It's just that I think there's two parts to that, right? The first bit that you just discussed is purely a documentation, to more clearly and completely document what it means to get a package into, a quote unquote official Koji, and then end up with an artifact out the back end. But then there's also, the more approachable and more complete set of documentation for how to stand up your own environment, and then efforts to make, it easier to, like, more push button to stand up an environment as well, right? So I think there's a few different efforts that could make Koji a lot more approachable and self-service and more widely adopted. So
Is there the expectation that users of the SIG or people who are contributing to the SIG will do that, set up their own environment so they can build their own customized version of the CentOS Automotive spin? Or is it expected that all of the work that they've done here will simply be done here? I mean,
I imagine anything that's in the SIG would go through the SIG's
right. I
setup,
guess my question is, how would people consume the artifacts that we develop within them?
Right. I mean, I'll give it an initial read on that. One thing we've talked about, and that some early work that Steve is looking at, is that we would like to make it easier to have a sort of plug and play package build and curation solution that people could use. And that would be for things that they wish to keep internal, that is not necessarily public development. And we would want it to essentially make it easier to create these infrastructures that I think are a little hard fought in places like the SIGs or at IoT and elsewhere. So, which I think is good. It's not necessarily that everyone would want to do that, but I would assume that the workflow for people who want to contribute stuff visibly to the SIG would mirror what happens for people who own and maintain packages in Fedora or in Apple or things like that, where it's pretty typical that if I'm a developer that has in the Zen SIG, let's say, I don't think I have my own Koji associated with my workstation, but that doesn't mean that I'm not building packages that might eventually find their way out in the SIG, but I'm just doing it in the more individual developer workflow. And if I want to do it collaboratively, I do it in the infrastructure that the SIG provides. When I want it to be permanent or semi-permanent, I'll do it there, and I can make it visible. So in the SIG context, that's what I would hope to see. I think what Steve is alluding to is we want to make it even easier to spin those up, easy enough that people could even do it on site if they wanted to, but that should pay dividends in our, hopefully if we do that right, the experience we're having right now of adding packages will be even easier out here as well. That's my take on it.
Good.
I'm really kind of curious, as long as we have this rare opportunity to speak to someone else who is also maintaining a long-running Koji infrastructure to build a large set of packages, possibly a whole distribution's worth. And Stefan, am I pronouncing your name correctly?
Yeah, sure.
Okay. I'm just curious what your thoughts are, and here, like
Yeah, I think we have, from what we see from our customers, we have two populations. One is integrators in population, which I would say that mostly those people want to write spec files, to adjust the dependencies, to make some QA, ensure that everything runs fine with all the packages in images, and you want to create images from that.
Mm-hmm.
And for that you need Koji, because Koji, Kochai, and Fungi and the rest, because you need to assemble everything and ensure that everything is correct to deliver at the end a kind of release or snapshot or candidate or whatever the name is. So that's for the, I see that as the workflow for integrators. In that case, Koji is necessary. You need to have a factory somewhere in the cloud which is shared amongst your population of integrators. But on the other side, as a source developer, you want to minimize the loop. I mean, your development loop should be only local. I mean, if you look at what Yocto does, they ship an SDK which you are supposed to install on your laptop, and you build and you change your sources with that SDK. Roughly, you could be in a position where you build an RPM, and you want to test the RPM on your target, right? So your loop should be, in my opinion, it should be only local. But at the end, one thing which is important is that you should replicate locally what is done in the factory. I mean, in the target, on the target, the developer target, if you have some containerization technology you want to use to isolate things, if you want to use a specific LSM at the kernel level for security, then the developer should use also the same. You should have a target with the same setup as the one you ship on your factory, because at some point, while developing your source and testing locally, you want to be in the same position as the one you would have if you take the image which is produced by the factory at the end. That's important because in that case, you look very quickly locally as a developer, you validate your code. You don't have to commit anything on the Git. You can build on the fly from your IDE. You still deploy an RPM somehow on your target. You test it and you make your loop. And when you're happy, then you commit somehow the sources. Maybe you will push the one step further, saying now I want to create a spec file and integrate, etc. But usually what we see is that the spec file is somehow, usually it's more and more stupid because you have your CMake files which probably do most of the jobs. So from what I see from my experience, the spec files are more and more reduced, and if you start from a skeleton, then you just have to do some adjustments and you're done. I mean for automotive components, right?
Yeah.
I
know why Clark is laughing. Yes,
it's like the world's worst spec file ever.
You want to talk about an example of bifurcation? Like it is true. I think in a lot of cases, people are trying to make the spec file almost an automatic thing. Where just the kernel is the notable exception.
That's clear. We know it.
Yeah.
Because
no,
we had to
adjust
the BSPs from various vendors and
It's interesting. That workflow, your outline of that workflow is really helpful, and a lot of it sounds familiar. I will say, like, it reminds me that in our experience, my limited experience with Yocto, I think it's probably still better placed for a developer to have higher confidence that the local build they're doing is using exactly the same set of things as the remote build. I think that's one of its strengths, and it's mostly by being essentially a mono repository at the end of the day, or just a handful of them. It's just a little bit better, whereas the workflow that's associated with Koji and Fedora and RHEL is a collection of, it's a pipeline of tools, many of which are maintained in a very centralized way and have a specific configuration. So.
Yeah, even if Yocto they try to do things correctly, but at some point the SDK as it's done and built is still failing on some points, in my opinion. But the concepts are there, and I can tell you what we did. Also, one thing which is interesting from a development point of view, that's from our experience in the automotive grade Linux project. Okay, they are using Yocto, but what we saw from the beginning is that maybe but there, as you build, you cross-build all the sources for your target, but at some point you mix the native and the target architectures and files, etc. At the end, in the past, there were some pollution between the native and the target sources, or you may have some pollution between both. And this is something which already you can have some pollution, and it also depends on the host, on the build host. So it depends on your distribution. And so what we saw in the past is that whether you were with your Debian or Ubuntu or Fedora on your host, you get different results, even if you pull the exact same layers, okay? Because the pollution also comes from the host. And so it was a nightmare to debug, of course. And to avoid that, we pushed the idea to have a container. It was a Docker container at the time, to have a homogeneous environment for the developers to build. And so that's an idea we kept in Reddesk. And so now what we do is we don't ship a Docker container, but we ship what we call a local builder, which is in fact a LXC container based on CentOS, in fact. So it's a egg and chicken problem, but it's funny. So you have your container, and you can install your full toolchain, your cross toolchain inside it. You have multiple toolchains even inside the same container because you want to support multiple boards. Okay, your Raspberry Pi, you also your QEMU or whatever target, whether it's real or virtual. And so at the end, you have everything in the container, And as a developer, when you are in the IDE, you just have a kind of plugin to interact with that container and build the sources inside the container with RPM build and the usual tools, right? So if you look at what is inside the container, you will see just some normal tools to build RPMs, basically. So but the idea to ship container for the developers is, in my opinion, a good idea, because when someone reports a bug or has an issue on sources, and you can ask them, yeah, what's your version of your SDK? What's the version of your container? What's the version of the RPMs which are inside? And so the bug reporting is clear and reproducible, potentially. So that's also a strong, in my opinion, it's a strong element in the development workflow, which may not be necessary at the beginning, but to be honest, it's a big help when the project has more and more developers, because you know that they're working on the same platform.
I saw a lot of nodding amongst people with past experience cross-compiling. Stefan, can you remind me, do you actually have you extended Koji to allow for cross-compilation? Do you have cross-compilation going on in there?
Yeah, definitely, yeah. We had to, yeah. We had to, once we have some plugins on top of RPM. We tried to do everything with plugins inside Koji. I'm not the one who wrote all the code on Koji side, but I could ask my engineers, well, what are the parts we had to tweak. But as far as I know, we tried to do it cleanly, because we didn't want to maintain strong modifications inside Koji. We want to be able to rebase easily. So I hope that everything is done in that way. But at some point, if you have to do tricks inside, you have to do it. So
yeah, I know. I'm pretty confident that we don't do it at all, even though there's some vestigial capability to do that within RPM build. That we've in the core distributions, we've always been able to stick to having native builders.
I think we're going to have to wring out the cross compilation macros and logic, because trying to everybody's going to want to be able to do a local build. You're not going to want to have to say, oh, well, let me package this thing up and ship it off to Koji to build it. You may want to say, I just need to try this one thing, build it. And trying to do it on a Raspberry Pi 4, well, that's way better than trying to do it on a Raspberry Pi 3, but that's still relatively bad compared to doing it on a 3.5 gigahertz i7 with 64 gig of RAM and, a couple of terabytes of disk space.
I'm also waiting for RISC-V to see what will happen.
Okay, don't hold your breath. But I think we're going to have to make sure that the process for doing cross compilation on an x86 64 with a ARM64 target works. And I haven't done it in a while. It's been years since I was seriously into the embedded world. And so this is going to be, what I'm working on for the next couple of weeks, is saying, all right, let's take the Fedora cross toolchain for ARM and try and start cranking out real-time kernels that'll boot on a Raspberry Pi 4. Yay.
In fact, cross-building a kernel is not maybe the most difficult part, because you don't have much dependencies. One thing I recall, which maybe you guys at Red Hat could help to solve that, but one thing we have, as soon as you will cross-build things, you will hit the same issue as Yocto, which is somehow you need to have some build requires which are on native dependencies and others which are target dependencies in the same spec file, right? And so in the semantic of spec files, you don't make any difference between. Obviously, you have only one target. In fact, you are native, so you don't make any difference between your native dependencies and target dependencies. And so right now, what we did in RedPesk, one solution was to make the spec file format evolve the schema and introduce something like native build require or something like that. Okay, it was too difficult for us and too difficult to impose that to any upstream project. So what we did is it's really stupid, but when you build require something, then in the sys root we install both packages, the native one and the target one. And so depending on which one is picked, you always have the one which is right, which is installed. But okay, that's something which is definitely missing in the base architecture or the base concepts, because it's understandable at the time where RPM was created or designed, we were not talking about cross-compiling RPM. So, but yeah, we may have some thoughts about that on the long term, maybe. For now, we just have some workaround which works, but could be better. And that said, just for cross-compiling, what we hit also, we had to modify many macros, but at the end, that's okay. Hopefully, we have RPMs, macros, which are mostly right. Okay. And then at the end, to bootstrap things, we had to patch, let's say, something like, I would say 800 or something like that, packages. I mean, the base packages had to be patched to build, or some packages don't use macros typically, but they should. And so that's not a big deal, but on the long run, it's still an issue because you want to maintain your patches on top of the spec files for years. So, but that's something that could enter into upstream, I think. Yeah, I really encourage you to take a look at RedPesk, and we publish many things, mostly about the distro by itself, and not much on the factory side because it's our business, in fact. But we want to upstream a few things because we don't want to be alone to maintain everything. So at some point, yeah, we can open things, and definitely CentOS Automotive is probably the right place to do so.
Quiet group this morning. One other thing we could discuss is hardware. Raspberry Pi 4 seems to be the one that people keep coming back to.
Cheap.
Cheap and ubiquitous and readily available to everybody.
Yeah.
That's a song waiting to be written as well.
I don't know. I'm not sure I could work ubiquitous into a lyric.
No, just the almost romantic way that Jeffro framed it is that we all keep coming back to the Raspberry Pi 4.
Oh, okay.
Yeah.
As long as I don't have to try and rhyme ubiquitous, I'll be happy.
A cheap and reliable friend. Yeah. Raspberry
Cheap and reliable. Then it sounds like a country song.
You can almost rhyme ridiculous with it, but
why can't I quit you?
Yes.
Exactly.
Get
a truck, since this is a vehicle OS, we can get a truck into here and it becomes sentient and decides to leave us. Then we've got the absolute best country song.
New country
Drive
song,
the
yeah.
Chevy to the levee.
Right.
And it left me.
Yeah.
Oh, but the levy was pi?
Oh, oh.
Did you,
All right, now you're trying to drive us away. Drive us.
So anyway, I think it's like one thing that, on the hardware side, we anticipate continuing to have activities to help enable hardware. And I don't know the extent to which that, I don't know how the SIG contributes to that, frankly. I think that's a really interesting problem we have. Clark has some salvaged hardware somewhere in his background or in a storage closet right now that was used to try and automate the process of hardware bring up in a collaborative way, as opposed to the way that another person visible to me, Al, is doing it with a board that's on his desk, or was doing it with a board on his desk. So I think, if we up level it and zoom it out to that broader problem, I think it's something that, as far as I know, there's no great generalized solution for. Unlike in the server space where we have standardization for remote access, or at least a reasonable amount of it.
Mm-hmm.
So putting stuff on your desk is going to be hard for for anything much more than the Pi. But the other thing to be aware of is the Graviton instances in AWS are phenomenal, and there's a very, very broad range on those. So probably one of the best parts about it is a lot of them have ISA features that aren't necessarily available in some of these small dev boards that we might be seeing later on in Auto. So, for example, I don't know, needing to cross-compile something, maybe toss it out on a Graviton instance and have it go. Now, I don't know what that means from a CentOS side, right? I mean, I doubt seriously there's a CentOS account that we can just use and freely use AWS as much as we wish, but
not at an individual level, no, I don't think.
No, it would be nice, but
no, and I mean it's interesting because it gets back to the workflow we were talking about. On the other hand, as a SIG member, you can probably do as many scratch builds on Koji infrastructure that has native builders as you want. But I would draw that distinction. Like Al, what you're talking about is basically I, as a developer who only have x86 hardware, would like a reasonably snappy native 64-bit ARM or some other, if there's some other architecture in play. And that's relatively straightforward. I think, the more challenging activity that's going on here would be hardware bring up.
Right.
Yeah.
Well, the other thing to consider is, depending on the extent to which ACPI and UEFI become standardized in this space, there is a version of QEMU that does a full server-based standard implementation. Right. So you can actually experiment with those things in QEMU on your desktop, and that's kind of handy. QEMU is also very, very capable when it comes to all the various and different ARM emulations. So there's a lot of potential there, and it wouldn't hurt to if you break something to send another upstream patch. But so there's a couple of possibilities, but it's if you actually want real hardware to work with, there's unfortunately there's some nice IMX options as well. Not as much standardized support there, but Renaissance is used quite a bit in automotive, so that's a potential. NVIDIA's hard to say. That's going to be, I think, more of an issue of availability at present. There are some dev boards that are Snapdragon boards if you want to work with Qualcomm CPUs. Now, will those boards look anything like an actual automotive product? I don't know. Hard to say. But there are some nice SoCs out there from like 96 boards and some other places.
They're not cheap either.
No, unfortunately. Some of them are $600-700, which in the ARM space is very, very expensive.
Well, again, it's our our reliable friend, the Raspberry Pi, has set the floor so low.
Exactly.
Yeah.
So.
Set expectations low. There are a number of those boards that do have things like CAN bus and other things that are interesting to offer. I believe the new Beagle boards, the latest Beagle boards, blacks also
Really?
all have CAN bus support.
Oh, do they?
I don't think they have. I think they have the fives. I don't think they have the actual hardware.
Don't you need a cape for that, or I mean a shield
Yeah.
or something like
Probably
that?
do need a shield for the actual hardware, but the
Well,
support.
I can give you some feedbacks from AGL project where they have a few reference boards and also they want to introduce community boards. As Renesas is a big sponsor of AGL, obviously the Renesas boards are supported. Not all the boards, in fact, because Renesas they sell some development boards which are quite expensive. But full featured. Instead of that, they developed some small. They call them ULCB board. So it's a ultra low cost board. Ultra low cost for them means something like $700, something like that. So we don't have the same reference, but definitely it's not so expensive in the automotive world. So we have some Renesas hardware. We also have some Intel stuff. I'm not sure how it's very well tested, supported, or whatever, but still we build HL for upboard or upsquare now. I don't remember which board was taken as a reference one, but let's say a small Intel board based on Atom. Which is still a good idea to have, even if we know that we probably want to build for AH64, but having another architecture sometimes helps because you can compare things, you can do things, yeah.
It might
so
be
you can
nice
build natively.
From the SIG perspective. It might be nice if we could come up with a set of recommendations for manufacturers to say, hey, assuming that every developer is going to have a reference board sitting on their desk is not really realistic these days. And maybe they could make their reference boards a bit more remote access friendly. Because I know we've got some boards in-house that the only way to reprogram the flash is to actually physically change a dip switch to enable writing. Stupid thing.
Yeah, that's an issue. Yeah. And so just one small comment regarding what it was Albert that who commented just before. From what I see in the embedded world, as soon as you have a board, you have a specific BSP or somehow. Maybe they try to make the same BSP for multiple boards, but you always hit some limits, and it means that you for example, the UEFI normalization is enabled on ARM boards, but not all boards. Right. And so if you think that you can unify things by using the standard, that I think it's no way, because every SOC vendor will do as they want for any given board. So.
Well, definitely not this week. Maybe sometime in the next decade that'll happen. But
Yeah, I agree.
Right.
We have a build farm, or no, a test farm, I would say, in our labs in Lorient. We use Lava we have a pool of boards,
right.
A few Raspberry Pis, a few Renesas boards, IMX8, some solid run, a few things. Okay, Beagle boards also.
Solid run.
And so,
forgot about them. Yes, good stuff.
Yeah, there are plenty of them. So, but what I see is that it's a jungle. Okay, in the Intel world, everything has been normalized, and you can do things quite easily. Even for embedded stuff, right? Because it derives from what has been done in the server side and desktop side. Right. But in the embedded world on ARM, it's a real jungle. So at some point, what we did, just a hint, is that we saw that the fastboot protocol is implemented somehow in in U-boot, right? And U-boot is a common denominator for all those boards. Even on Intel architecture, you can run U-boot in UEFI mode. And so our idea to flash the boards is to enable fastboot on a specific U-boot incarnation for each board. So that's a specific work for each board, depending on the BSP coming from the vendor. But as soon as you put your own U-boot with fastboot support, then you're done. And you can have a uniform way of flashing your boards, or quite uniform. It's not perfect, but that's the first result we had very recently, because we made those tests last week, in fact. And so the conclusion is that using fastboot is a good idea. One thing which is not perfect for me is that fastboot could be used with USB or Ethernet. And the USB side is very well documented, maintained, etc., because it's used everywhere in the mobile world. But the netboot side or Ethernet way of doing fastboot is not well maintained. So, but that would be perfect for us, because you can imagine your pool of boards. You just have to plug your serial cable, which is varying from one board to another again. But that would be the only thing varying. For the rest, you plug your RG45 plugs and you're done. That was my idea, at least. But
little serial cable here.
Mm-hmm.
You still need the serial cable to control your board, to boot.
Yeah, I mean this is going to be an issue, I think, in the SIG ultimately is how do we make sure that we can distribute all the right pieces for the right board, right? I mean, a lot of folks want, what I'm seeing is a lot of the automakers and those sorts of folks want to have some standardization because, they see the same jungle and they think it's insane. But,
part of it, Al, is the functional safety side of it.
Right.
We can use the exact same bits across a wider selection of hardware. We have a stronger functional. So, if we can use this, the goal from my perspective would be to say, let's build an AR64 kernel, one of them, that'll boot on a Pi, on an IMX board, a Beagle board, a Renaissance, and we either use ACPI or DT to describe what we're on. Obviously, when reality meets idealism, we may have to change a little bit, but right now since we haven't dived deeply into reality, we can say in our little fantasy world and everything, it's all going to be one kernel, it'll be great. So that's to me the idea that we can share as much is key here, and the more we can do, the better it helps the functional safety story that says, look, we've reviewed all this crap, we've tested the hell out of it, it's safe.
I guess the question in my mind is, like Stefan was suggesting with fastboot, right? We can argue ad infinitum whether or not that's the correct solution. But if we come across a solution like that in the SIG, is it the role of the SIG or the individuals to say, look, we've got a solution that solves this problem that simplifies the jungle and at least cuts out some of the larger trees, and try to push that in the industry at large? Or is it just kind of the CentOS SIG will recommend it, and if people use it, that's awesome? That question makes sense.
I think the SIG has a position which is not the same as the one we have as a single company. So that's clearly the organization where you can push something better than a single company, I think. And that said, I have some good news for you, Clark. We made some tests recently also, and we have a generic, or not so generic, but let's say a vanilla kernel running on Renesas and IMX8. So that's the same kernel, right?
Yeah.
So it works.
I think it can work.
Yeah, it works, definitely. But where we have some limitations is that when it comes to the long-term support for your kernel on a specific board, you can take a look at what Renesas is shipping. Okay, they ship a Yocto layer, but besides their Yocto layer, they also have a kernel, and the kernel with many patches on top of the vanilla kernel. In fact, they have both activities. They want to push their patches into the mainstream. That's one of the main contributors to the kernel, right? But on the other side, they have to keep some patches for them because it's not accepted yet, or because their customer need the patches, but it's not in the vanilla kernel. So yeah, you have two categories of patches. And somehow, if you want to go a bit further with your board, you will need those specific patches in your kernel. So that's a limitation. But I would say it could be the same for Intel architecture. You could have some specific patches for your last Xeon CPU or whatever.
Oh yeah, we got a few
that's a
of those.
Limit. So that's the limit. But that's a good news still, because if you look in the past, when we were talking about ARM 32 bits, that was a nightmare, right? Really a nightmare. Now you can have a single kernel booting your single architecture, and you may have maybe the GTB that changes from one board to another. And even in Renesas, what we managed to do very recently again, it's to have a single kernel for a family of boards, which is already hard to achieve. But clearly on the CI side, it's the holy grail.
Sure.
That's what you want to do.
Unfortunately, I'm going to have to bail. I just got a SIG wife, which is non-maskable. Therefore, going to have to leave.
Trying to call it SIG spouse now.
Big SIG spouse. Okay, sorry.
Yep. And we're reaching the top of the hour as well. So there's also I don't know if everybody sees, there's an active discussion about hardware going on in the chat as well, parallel to this. So I'm definitely going to hold on to this and save it so that we can noodle on it and maybe bring it up at the formal meeting in a couple of weeks.
Sounds like we need to maybe next SIG meeting come up with what's our chat platform or platforms, and so we can carry these discussions over and argue. And I would vote for IRC, but then again, I'm an old reactionary.
Funny you should mention there actually is an IRC channel for the CentOS Automotive.
All right. Maybe that's the place for us to continue the discussion.
Yeah, we can certainly continue it there.
All right.
So let's aim for that and keep talking about it. And
yeah, with pleasure.
And we'll
see you guys later. It was fun.
All right. Good to talk to everybody.
Yep. Great conversation.
Thanks for setting it up. Bye.
Bye.
Thanks. Bye.